So we're going to be doing a lot of things that look familiar, but we'll be using new symbols. Right? So the operators perform for operators on functions. That's just add, subtract, multiply, divide. That's no surprise. We've been doing the first three an awful lot. Dividing, not so much. We did in Algebra 1. We did this dividing in Algebra 1, but it's just going to be basic stuff, nothing just too crazy. The composition of functions, that's like plugging a function within a function. So you guys are used to plugging in like what's f of 1, what's f of 2. So it's similar to that, but we're going to be plugging in an expression. Instead of plugging in like a number, we'll plug in what's f of x plus 2, what's f of x plus 3, or something like that. Where are we going later in this chapter? Well, kind of just join a little bit. The first few sections are about this, the next few sections are about that. But in the big picture, we're heading towards this. What happens when you graph this new function? Now we've been graphing a lot of stuff. First it was linear, then it's quadratic. Then we did polynomials last chapter, so we're going to begin into this, graphing square roots. What happens when you graph square roots? So what does the square root of x look like? What does square root of x plus 2 look like? What does the square root of x and then plus 2 on the outside look like? How would that compare if I was going to graph, this? Remember from here for quadratics. Well, this moved the graph one direction on one axis. This moved the graph on one direction on another axis. You can see a lot of similarities between quadratics and even the polynomials, as we will here. A lot of similarities. That's the idea. We get into graphing quadratics. Square roots. Okay. Following chapter, we'll begin graphing power functions. So what does 2 to the x look like if you graph that? It's kind of related to this, because remember, square roots are just fractional exponents. Somewhat related, so this is kind of where we're heading. Today, it's just going to be mostly notation. Here's the 3 types of problems we'll be looking at. I'm going to give you 2 functions. You'll have to add, subtract, multiply, divide them, and also talk about the domain, where the bottom function cannot equal 0. Then I'll give you a couple functions. And this is what I said. You're going to plug one function into another function. Not necessarily a number, but the entire function. So like you might take 5x and plug it in to both of these x's. And also finally, we're going to plug a number into a function, get an answer, plug that answer into a different function. Most of this is going to be notation, is what's going to be new, but math is going to be very familiar. So kind of equated to what we did last chapter, where we said f of x approaches infinity as x approaches infinity. All this meant was, hey, the graph goes up on the right-hand side. A lot of notation just to say something very obvious. But we had to know how to write it properly. Okay. So same thing here. If this is going to be very obvious on how to add, subtract, multiply, and divide, we just have to use correct notation. That's going to be the little part. All right, so let's start off here. First example. So all of this means, if I'm going to add 2 functions, means, well, take your f of x. Technically, you want to use parentheses. Take your g of x and add them together. Okay. What does this equal? If you add these together, 5x plus 4. Now, when did you learn how to do that? Sounds great. So again, the math here is familiar. It's not so much how do we do this, how we're going to solve this. It's, okay, I don't know about this new notation, adding 2 functions. Maybe this notation right here. Notice how these are the same thing. It's getting used to the new type of symbols. But mostly we know how to do this. Subtraction. And what do we get here? So distribute the negative, of course. Negative x minus 1. What about multiplying? Do that too. 2x times 3x plus 4. What does that equal? 6x squared plus 8x. So far, just something we've been doing a long, long time. Here, division, like I said, we've done this before, just it was in Algebra 1. Let's go ahead and divide. Okay, so 2x on top. 3x plus 4 on the bottom. Now, does anything simplify? It's a fraction, so you have to look to simplify. Does anything simplify here? Go ahead and say no. No, nothing simplifies. I know there's going to be a few people that say, what you're thinking, if you said this simplifies, you're thinking of this. 3x times 4. If this is the case, yeah, the x's cancel out, the 2 cancels with 4, all the stuff cross cancels because it's multiplication. This is addition down here. Different set of rules. So going back to the original, do 2 negatives make a positive? Not all the time. When you're multiplying, you do those rules. If you're adding, 2 negatives make a negative. You do those rules. So we can't just take all the rules where we can cancel this and this and apply it to every fraction from now on. It's only when it's multiplication are you allowed to do that. So here, yeah, nothing cancels out. Now there's one other thing we have to worry about, and they're written down below. There are some restrictions for domain. Okay. The first one is the only one we're really going to worry about today. Second one talks about fractional powers. That'll be after the break. Start doing a lot of fractional powers. And the third one is a little bit later too. That's the absolute value and square roots and things like that. But for now, you guys remember it's okay to have a 0 on top, right? It's okay to have a 0 on top of a fraction. But no, it's not okay if there's a 0 on the bottom. You cannot divide by 0 in any math class at all. If you put in your calculator 5 divided by 0, it says error or domain. It doesn't work. In calculus, we try to get around this. We'll see that maybe a little bit later. But for now, we're not going to mess around with it. We cannot have a 0 on the bottom. So if you have a variable on the bottom, you have to say, well, x can be any number except that one number that will give you a 0 if you plug it in. A 0 on the bottom. We don't care about the top. Top's not a big deal. You can have a 0 on the top. That's fine. So we could plug in 0, right? 0 would be 2 times 0, 0 on the top. That's fine. It would be 0 over 4, which equals 0. You just can't have a 0 on the bottom. So what you're going to do is say, I do not want the denominator to equal 0. So I do not want 3x plus 4 equals 0. And the way you say that mathematically is 3x plus 4 should not be equal to 0. It could be any other number, but this bottom, denominator is at 3x plus 4, it cannot equal 0. And then solve for x. So anytime you do division, also automatically have to do domain. You have to account for this. It's only on the bottom. We only care if there's a 0 on the bottom. Top doesn't matter. So then, of course, go ahead and solve. What is this value of x we cannot have no matter what? Factor 4 on both sides, so 3x cannot equal negative 4. Therefore, x cannot equal negative 4/3. So 2 parts to the answer for division. The actual expression function here, as well as the domain restriction. We cannot have x be negative 4/3. If x is negative 4/3 and we plug that in, yeah, the top we would get negative 8/3. That's not a problem. But the bottom, 4 times negative 4/3 would be negative 4. Negative 4 plus 4 would be 0. And that's where the triple would start. So it could be any other number, just not that one. And I think I'll focus mainly on, this one today. I'm going to trust that you, like I said, long time ago you guys started doing this. So really here we'll focus on. And we'll talk more about 2 and 3 when we start doing fractional powers in a little while. Alright, so a little practice again. I'm going to assume for now you guys can add 8x minus 3 and 4x plus 5. For multiplying, you guys can multiply out 8x minus 3 and 4x plus 5. You can draw a box, multiply those out. That's not a problem. But just for the dividing, let's look at the dividing together. All right, f of x, f is on top, as you can see, f's on top. So 8x minus 3 over 4x plus 5. Does anything reduce? That is always the question. Anything reduce? And then you say no. Nothing reduces. Very tempting to start saying, oh, this, 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 and this. But remember, it has to cancel out with everything. Good example that we've already looked at is like 2 plus or minus 4 root 3 all over 2. When you simplify this, did you just divide the 2? Or did you divide the 4? Or did you divide both? Yeah, do both, right? Same thing here. That's why we can't just cancel out, oh, 4 goes with 8. What about the 3? You can't just divide by 8 but not divide by the 3 by 4, and that doesn't make any sense because it'll go evenly. So as soon as things start going in evenly everywhere, then we can start doing the simplification. Okay, 2 goes into 2 one time, 2 goes into 4 2 times, so it's 1 plus 2 rad 3. And then we can do that. But look, we're not just going to pick out like, well, we like that and we like that. And let's forget everything else. Can't do it. So that's as far as this goes. That's the first part of the answer. And again, the second part, do you work with the top or the bottom? Bottom. And what do you set that to? Not 0. So this bottom can be anything, but it just can't be 0. So 4x plus 4x not equal to negative 5. Notice how we just do the same old steps. X is not equal to negative 5/4. Plug in negative 5/4, so you'll get 0 on the bottom, and the world ends. Just might. Messing with things you don't have any business messing. Like going to Google and then trying to Google. You know, you don't want to go there. Alright, so go ahead and let's do a little bit of practice here. Let's skip forward to the homework. Go ahead and try 14 through 17. Give it a go. Pause this here. There we go. Alright. Following that, we're going to look at something called composition of functions. So what you guys just did was the operations of functions, just add, subtract, multiply, and divide. But one thing we can do, if we have 2 or more functions, we can find or use a composition of functions. So the hard way of saying this is that you take an output from one function, plug it into another second function, and then also. Or another way of looking at it is, you ever had a certain problem where, okay, first plug your information into this problem, and then when you get that answer, plug it into this other problem over here, and that'll give you your final answer. That sound familiar at all? Done in a couple different ways. The most one you might recognize the most was this. What if I asked you to find the vertex here using the formula? What'd you do first? Probably this. First thing you did is, okay, what's negative b over 2a? And then you got, okay, that's negative 3 over 2 times 2. So we got, what, negative 3 over 4, right? And then what'd you do with this answer? Oh, positive? Positive. That's negative. Okay, so we got positive 3/4. Then what'd you do with this answer? You plugged it back into here. Okay? That's kind of what we're about to do. You're going to do a problem, you're going to get an answer, that answer you're going to plug into a different problem. So it's kind of like solving 2 problems at once. First you plug into the first function, get the answer, plug that into another function. Okay? So again, the notation is going to be new, but what you're doing is pretty basic. It's pretty familiar. Don't let the notation get in the way of understanding what's going on here. So for instance, this says, find out what g of 1 is, get that answer, plug it into f. So we say, okay, g of 1, I know how to do that. There's the g function. G of 1 would be 1 plus 4. So g of 1 equals 5. So that's kind of like that first part we just did. Now take 5 and plug it into the f function. All right, plug in f and 5 into here, and you get 3 times 5, which equals 50. So it's like doing 2 problems. It's just the second problem depends on your answer of the first problem. If we don't do the first problem correct, we'll plug in the wrong number into the second problem. Another, I'll show a little more steps here. So h of -3, so I'm going to go up here and say, okay, it's -3 squared minus 1. It's the h function, plugging in -3 for x. All right. What does this equal inside here? 8. Now, switch to the g function. What's g of 8? That'll equal 8 plus 4. Which equals 1. Question? How do I get what? 5? Okay, plug g of, that's what g of 1 equals. So g of 1 equals 1 plus 4, which is 5. G of 1 equals 5. These equal each other. That's why I'm allowed to take out g of 1, substitute in 5 in its place. So yeah, h of -3 equals this, this equals this, and g of 8 equals 8 plus. So again, it's what's the calculations going on here? If we're squaring a number, adding a number, subtracting a number. And mathematics is basic, right? It's just kind of getting used to notation and not getting lost in the little details. But if it seems very simple, that means you probably get it. You mean I just take that answer, get that answer, plug it in this other thing? Yeah, that's it. New notation might not be familiar, but yeah, you know the math. Trust yourself. Okay. That being said, what is h of 0? Let's do these verbally. What's h of 0? Over here. What's 0 squared minus 1? All right. So what's g of -1? So you find the g, -1 plus 4 is 3. What's f of 5? 15. Okay, so what's h of 15? 15 squared minus 1, 2.4. Okay. Yeah, it's actually almost easier to do verbally than to write out the new notation and try to figure out what it all means. What does that equal? H of 8? What does it equal? And then what is f of 63? And 89. Good. No problem, huh? So, let's have you guys practice now. Back to the here. Start on 34. 34 through 44. At the end here, we start doing 3 functions. I want you guys to try that out. But yeah, it's just the same. Find out what g of 3 is, get that answer, plug it into h, get that answer, plug it into f. You kind of work right to left on these. Start with g of 3. Ooh, it's supposed to be an arrow. Not a very good one. Start here, work your way to the left. pause this one. So there's two parts here with the composition of functions. There was the with a number, where you have a number, plug it into a function, but there's also without a specific value of x. So we're not actually plugging in g of 5, h of anything. We're plugging in the actual function, a whole expression, whatever it is. We're going to plug all of g of x into f of x. So we're going to take this whole thing and plug it in for x. So take all of this, plug it in, plug it in. So instead of x plus 3, we're going to plug in x squared plus 4 into here. X squared plus 4 plus 3, which is x squared plus 7. So plug in the whole expression, not just no number here, but same idea. Just take this whole thing, plug it in for each x over here. And we can also do the other direction. We can take f of x, this whole thing, and plug it in for this x right here. That's the other direction. So we can take f of x, plug it in for g. So instead of x squared, it's going to be x plus 3 squared. So in either direction. Now, if this had more x's, I'd plug it in for every x there was. So far, we're just really keeping the basic with a basic x, one variable per function. Of course, simplify this. This does not equal x squared plus 9. If that's not obvious right away, you need to do this on every problem. On the side or somewhere else, scratch paper, and actually write it out. The last thing you need right now is to be assuming this is, assuming your answers are right and making easily catchable mistakes. Okay, all you have to do is write it out, and you can see, you get 3x here, 3x here, then altogether makes 6x. So we have here x squared plus 6x plus 9, and then bring down the plus 4. Right, with this being so simple, these should be easy points for you. We don't want you messing it up because, once again, I'm just going to make up my own rules that nobody's ever told me to do. And square x and square 3, and hopefully that worked out. Show the work, show the work. Let me show you these two, just so you can see this. H of again, g of x. H of g of x. That means take g of x, right, and plug that in for each x of h. So I'm going to plug it in here and here, because there's two x's in h. So everything else had one variable. I'm just showing you, you don't just plug it in one time, but for every x that there is. So this would equal 5x quantity squared, you get parentheses, plus 5x minus 1. The parentheses are important here because you get 25x squared. Here it doesn't really make a difference. We're not raising it any power. Likewise over here, if you plug in x plus 2 and for x, what do you get? You get 2 times x plus 2 squared minus 3. How do you simplify this? What do you do first? What's that? Do this. Why? Exponent, then multiply by 2, then subtract 3. Don't start distributing and making up your own math problems, okay? You got to do order of operations. 2 times x squared plus 4x plus 4. Distribute the 2, then subtract 3. Alrighty. Have fun. Shouldn't take too long. Maybe a half hour at most.